Alright, this is the practice chapter 12 test, and as always I am the amazing Mr. Jansen. So here we go. If we take a look at these first couple, we're just doing factorials and factorial operations. The first one, 5 factorial, is just 5 times 4 times 3 times 2 times 1. Okay, that's what a factorial is. We just kind of count down till we get to 1. We multiply all those numbers together, and that gives us a 120. Okay? If we look at the next one, remember reducing these factorials is kind of like fighting a giant spider. We want to chop its legs off. So if I look at 27 factorial is 27 times 26 times 25 times 24 times 23, and then it would keep going from there. Okay. The 23 factorial would be 23 times 22 times 21. And see, right here, everything from 23 on down is going to cancel out. So all of these pieces are gone, which means all we're left with is the 27 times 26 times 25 times 24. And when I multiply all of those together, it gives me a whopping 421,200. Okay? And that's it. So remember, we're canceling out everything from 23 on down. We're chopping its legs off, and there it is. Okay? For the next one, we're going to do something similar here, except with this one, I've got a choice to make. I can either cancel the 52 factorial with the 2 factorial or the 50 factorial. And what I'm going to do is I'm going to cancel it with the 50 factorial because more stuff is going to cancel out. So if I cancel with the 50 factorial, remember 52 is like 52 factorial is 52 times 51 times 50, and then it would keep going. And of course, everything from 50 on down is going to cancel. So we're left with 52 times 51 over the 2 factorial. I'll still have the 2 factorial, which is 2 times 1. So I've got 52 times 51 divided by 2. And when I plug that one into my calculator, I get 1,326. Okay? For the next one, again, very similar. 87 factorial is 87 times 86 times 85 times 84. Okay, and we could write some of those out. 86 times 85, and then it keeps going. And what happens, this is 86 times 85 times 84. And what happens, all of this stuff, everything from 86 on down cancels. So in my numerator, all I'm left with is that very top number, which is the 87. Okay? Number 5, 0 factorial. 0 factorial is one of our special cases. 0 factorial is always equal to 1. Okay, and that one we just kind of have to remember. It's one of the special cases. 0 factorial is 1. Okay? Moving right along. Permutations. All right. With the permutations, remember we could do these by hand. The formula for a permutation is n factorial over n minus r factorial. So that would be 5 factorial over 5 minus 2 factorial, which is 5 factorial over 3 factorial. So really we're just left with 5 times 4, which is 20. Okay? But again, we could plug that one right into our calculators. When we plug it into our calculator, you plug the 5 in, then the NPR button, and then the 2. Okay? Next one, same thing. 7 factorial over 7 minus 3 factorial. So that's 7 factorial over 4 factorial. So that's 7 times 6 times 5. 7 times, looks like 210. Okay? But again, you can plug that right into your calculator. Combinations. Combinations are very similar, but remember the formula for combinations. I'll write it over here. It's the n factorial over n minus r factorial, r factorial. So we have that extra r factorial down there, which makes things reduce a little bit more. So this one would be 6 factorial over 6 minus 2 factorial, 2 factorial. So we've got 6 factorial over 4 factorial, 2 factorial. So that's going to reduce to 6 times 5 over 2 factorial, which is 2. And then, of course, I could plug this into my calculator, and that's going to give me a 15. Next one is very similar. Again, 7 factorial over 7 minus 3 factorial, 3 factorial. So it's 7 factorial over 4 factorial, 3 factorial. We can reduce it so it becomes 7 times, I should give myself a little extra room here since I'm going to have a denominator. It's going to be 7 times 6 times 5 over 3 factorial, which is 3 times 2 times 1, which is 6. I can cancel those out. That's a 35. Okay? And again, we can do this on our calculator. Let me show you how to do that real quickly. So here's my calculator. To do this on the calculator, like the first one, number 6 over here, if we're talking about number 6, you're going to go over to your calculator. You're going to punch in the 5 first. Then you're going to go to math over to the probability section. And there it is. NPR is your permutation. And then we punch in the 2. So it's 5, choose 2 for permutation. We hit enter and it gives us the 20. Okay. The combination, I'll look at number 8 real quickly. Very similar, almost exactly the same thing. We punch in the 6 first. Then we hit the math over to the probability section. And now we go down to combination and then the 2. So it's 6 choose 2 with a combination. And there it is, 15. Okay? So that's how we do it using the calculator. So back to our test here. If we take a look at this guy, it says how many ways can 4 books be arranged on a shelf? Again, we're still using permutations or combinations, but we have to decide if order matters or not. If I look at this one, if I'm arranging books on a shelf, that means that order matters. So when order matters, I use a permutation. And this one's going to be the permutation of, I have 4 books, and then I have to decide how many am I choosing, how many am I lining up? Well, all 4 of them. So it's a permutation of 4, choose 4, which we can plug into our calculators, or we can do our formula. It's going to give us a 24. Okay, for the next one, it says how many ways can a team of 3 be chosen out of 18 people? And for this one, we're still looking at whether or not order matters. And for this one, if we're just choosing a team, it doesn't matter what order we choose that team in. It's still the same team no matter what order we pick those 3 people in. So order doesn't matter. We're going to use a combination. And again, we want the total number, which is 18, and then how many we're choosing, which is the 3. And now we can just plug this in. And when you do that, it looks like we get 816. I should probably use a pen. Oh, there we go. 816. Okay? If we take a look at the next one, it says how many ways can the letters of the word race car be arranged? And again, that word arranged tells us that we're putting things in a specific order. So that means it's a permutation. However, if we look, if I were to switch the R and the R, it wouldn't change the word at all. So this is a special case. This is our permutation with repetition. Remember, permutation with repetition, we've got to do n factorial over p factorial, q factorial, dot, dot, dot. N factorial is the total number of letters that we have here, or total number of objects that we're arranging. So that's 1, 2, 3, 4, 5, 6, 7. So it's 7 factorial over. And now down here I have to represent my repeated values. And if I look, the r's are repeated. So there's 2 of them. So that's a 2 factorial to represent the r's. The a's are repeated, so I knew it 2 factorial because there's 2 of those to represent the a's. And there's 2 c's, so I need a 2 factorial to represent the c's. And now I just have to plug this into my calculator. I have to do the 7 factorial, which is 5,040. And then the 2 factorials are each 2. So it looks like when you plug this in, you get 630. Okay? Moving right along. Yeah, let's circle all my answers. Yeah, all right, here we go. If I take a look at the next one here, it says a standard number cube is rolled. What is the probability of rolling a number less than 5? Well, if I think about a standard number cube, there are 6 sides on a standard number cube. 1, 2, 3, 4, 5, 6. So getting a number less than 5, that means I could get a 1, a 2, a 3, or a 4. Okay? So there's 1, 2, 3, 4 options. Out of the total number, well, there's a total number of 6 options on a number cube. 1, 2, 3, 4, 5, or 6. So that's 6 options, so it's 4 out of 6, which is 2/3. And that's it. Okay, simple probability because I'm only doing one thing. All right, one thing at a time. Next one. One card is drawn from a standard deck. What is the probability of drawing a spade? Again, one thing is being done at a time. So if I want the probability of a spade, I will tell you that there, in terms of spades, there are 13 spades in the deck. And total cards, there are 52 cards. in a deck of cards. So, spades, there's 13 of them out of a total of 52, which reduces to 1/4. That's it. Okay, simple probability. It's how many ways the thing can happen over the total number of options. Next one, a standard number cube is rolled. What are the odds of rolling a 5? Okay, this time odds. Remember, probability is the favorable versus the total. Odds are favorable versus unfavorable. So if we're talking about a number cube, we've got 1, 2, 3, 4, 5, 6. Those are my options. If I want the odds of rolling a 5, well, there's only one 5 here, so there's only one way that I can get a 5. And then I want the unfavorable. I want to look at, well, how many ways could I get something other than a 5? I could get a 1, a 2, a 3, a 4, or a 6. So that is a total of 5 options. So the odds of rolling a 5 would be 1 to 5. Okay. If it said odds against, that would be 5 to 1. Okay. But look at this one. It says, given the probability, state the odds. Again, odds, favorable versus unfavorable. With the probability, since this is a probability, this is the favorable, and this is the total. Okay? So right away, I already have the number of favorable outcomes. The number of favorable outcomes was my numerator here, and that was 3. So there's 3 ways that I can get what I want. Okay? And then there's 7 total options. Well, if there's 3 ways I can get what I want, and there's 7 total, that means there must be 4 ways that I could get something else. Okay? There's 3 good things that happen, 4 bad things that happen, give me a total of 7. So the odds would be 3 to 4. Okay? When we do odds, it's favorable versus unfavorable. All right? Again, with this one, given the odds, state the probability. Well, odds is favorable versus unfavorable. If there's 3 favorable and there's 5 unfavorable, again, this is the favorable outcomes. This is what we want. This is the unfavorable, what we don't want. Well, that means there's a total. If there's 3 of these guys and 5 of these guys, there's a total of 8. Well, and if there's three ways that it can happen, it's 3 out of 8. Okay? Probability is the favorable versus the total. Odds, favorable versus unfavorable. If I look at this next one, it says a bag contains 9 green, 5 yellow, and 11 pink marbles. Find each probability. So number 18, if you pull 2 marbles, 1 at a time, and that is important, okay? That thing right there, 1 at a time. Saying that it's 1 at a time tells us that this is simple probabilities, okay? So I don't need to use any combinations or permutations or any of that stuff. Simple probability, 1 at a time. We want the probability of green, then pink, okay? And again, another key here is with replacement, okay? So the probability of green, let's start with that guy. Probability of green, there are 9 green marbles out of a total of 25 marbles. So it's 9 out of 25. With replacement means I pull that green marble out, I put it back, okay? So now if I'm looking at pink, there's still 11 pink marbles. And there's still 25 marbles total because I put that first green one back, okay? The word then implies the word and. It's and then, not or then, okay? So and means we multiply. So now I'm going to multiply these guys. And when I do that, I get 99 over 625, okay? And it doesn't look like that one's going to reduce, okay? And that's it, all right? But again, the key there was the 1 at a time. The 1 at a time tells us that it's simple probability. Okay?